Hello and welcome to another segment on linear programming. Today we shall be beginning with graphical method of solving an linear programming problem. Later we are going to discuss graphical method which uses corner point method, and finally we are going to deal with a numerical problem that would be dealing with graphical method of solving an linear programming problem. Now beginning with graphical method of solving an LPP, that is linear programming problem, the following theorems are fundamental in solving an LPP. According to theorem number 1, let R be the feasible region for an LPP and Z equal to AX plus BY be the objective function which is to be maximized or minimized. When Z has an optimal value, that is maximum or minimum, subject to constraints described by linear inequalities, this optimal value must contain at a corner point of the feasible region. The next theorem says that let R be the feasible region for an LPP and Z equal to AX plus BY be the objective function. If R is bounded, then the objective function Z has both a maximum and a minimum value on R, and each of these occurs at the corner point of R. Another thing that to be noted is that if R is unbounded, then objective function may or may not have a maximum or minimum value. However, if it exists, that means if there exists a minimum or a maximum point, then by theorem 1 it must occur at the corner point of R, which is the feasible region for an LPP. Next we are going to discuss the graphical methods of solving an LPP. There are basically two types or two methods of finding the optimal solution in a feasible region. One is corner point method and the other is isoprofit or isocost method. Now let's discuss the corner point method to solve an linear programming problem. In order to solve an LPP graphically, we need to follow the following given steps in case of corner point method. The first step requires the conversion of given constants into equalities and then drawing their graphs, which will be straight lines. The second step is to find the feasible region of an LPP and find the corner points. In the third step, we evaluate the objective function z equal to ax plus by at each corner point and let m and m be respectively the largest and smallest values. As discussed in the previous theorems, if feasible region R is bounded, then M and M are the maximum and minimum values of Z, and if R is unbounded, then capital M is the maximum value of Z in the open half plane given as AX plus BY greater than capital M has no point in common with the feasible region R. Otherwise, Z has no maximum value. And here small m represent the minimum value of z in open half plane ax plus by less than small m has no point in common with feasible region R. Otherwise, z has no minimum value. The last step is that if two corner points of the feasible region R are both optimal solution of the same type, that is, both give the same maximum and minimum values, then every point on the line segment joining these points give the same optimal solution. Finally, we are going to deal with a numerical problem that is based on solving the given linear programming problem graphically by the use of corner point method. The problem states that solve the following linear programming problem graphically. Maximize and minimize z equal to 60x plus 15y subject to the constraints x plus y is less than equal to 50, 3x plus y is less than equal to 90, and x and y are both greater than equal to 0. The first thing that we need to do is to convert the given linear constraints into equalities, and thus we have the equation of the form x plus y equal to 50 and 3x plus y equal to 90. Now we are going to draw the lines satisfying these two equations. The graph for this has been shown. This is y-axis and this is x-axis. Now starting with the line 3x plus y equal to 90, we have a line of this sort with 2 points A and B. The coordinates of A are 0 and 90, whereas the coordinates of B are 30 and 0. Now this line satisfies the line which is 3x plus y equal to 90. The second line, which is x plus y equal to 50, can be drawn as a line with points D and C. The point C has the coordinates of 0 and 50, and point D has coordinates 50 and 0. Now we define this point, let's say, as E, and this is O, that is your origin point. Now we can see that the points joining or forming the area, that is C, E, B and O, that is this shaded area, represent a bounded portion. Therefore we can evaluate z, that is objective function, which is equal to 60x plus 15y at each of these points, and E point here has the coordinates 20 and 30. Now we are going to evaluate the objective function, which is equal to z equal to 60x plus 15y at each of these points, that is O, C, E and B. So now we are going to divide this into two portions. One has corner points and the other has the value of z, that is objective function. Now corner point with coordinates 0, 0, that is O, will have the value of z as 0. The coordinates 30, 0, that is B, will have a value of z as 1800. The coordinates 20 and 30, which represent point E, will have the value of z as 1650, and the corner point with value 0 and 50, that is point C, will have the value of z as 750. Now as we can make out that the value of z is smallest at corner point O, that is having coordinates as 0, 0, and highest for coordinates value 30, 0, that is point B. This has the largest value. Thus the minimum value of z is 0 at point O with coordinates 0, 0, and maximum value of z is 1800 at point 30, 0, that is point B. Thus we have solved the given objective function graphically with the given constants, which has the highest and lowest values of 1800 and 0 respectively. With this we conclude the second segment on linear programming problems, where we have evaluated the method as to how to solve the linear programming problems graphically.